They can crawl. They can squeeze and hide. They can even use jet propulsion. And just when you think the octopuses couldn't get any more versatile, they up and walk away. And while it's utterly absurd to look at, once we stop laughing, maybe we should ask, why would one of the most agile creatures in the ocean choose to scamper backwards? That momentous question captured the attention of Dr. Chrissy Hufford, a senior researcher at the Monterey Bay Research Institute whose graduate studies at UC Berkeley focused on cephalopod behavior.
Generally, I try to understand how octopuses survive in their everyday lives, avoid being eaten, find mates, and find prey.
Documenting the survival strategies of octopuses isn't easy. You've got to be willing to spend a lot of time on remote tropical beaches.
My job is a lot of fun. I'd wake up at dawn every morning, get in the water, and get out for a brief snack at low tide, and then get back in until sunset.
It's hard work, but somebody's got to do it.
Unlike other octopus studies that had been done, I was actually able to follow individuals all day long on snorkel.
Particularly the cryptic algae octopus.
The algae octopus tends to come out during times of day and tides and in certain habitats that mean they tend to clump in the wild. And there are lots of individuals that use the same area and prefer that same area, so they're bumping into each other, mating, fighting, competing for similar resources. And I could watch this happen in real time and pretending I wasn't there.
Although on occasions, her subjects realized they were being observed.
I'm assuming that they considered me a predator in those cases. Octopus's main defense is not to be seen in the first place. That's their best chance of not being eaten.
And if all else fails, they can just jet away.
And in that shape, camouflage isn't even a possibility.
It was in one of these defensive moments that Dr. Hufford witnessed an entirely novel attempted escape.
I was working with a film crew for a documentary series called The Shape of Life. It was easy to get them to act defensively when you're chasing them with a camera, and we got footage of the coconut octopus walking on two arms. It was hysterical to see. We laughed and our masks filled up a little bit with water. Then later I saw the behavior in the algae octopus. We again laughed at how hysterical it looked, but also we understood the biomechanics significance of it. Octopuses have very strong arms, even though they don't have bones. They have three bands of muscles that oppose against each other, and the volume of those muscles and their arms stays constant as it changes shape. That's called a hydrostatic skeleton that allows them to use the internal pressure of their arms for support.
But just because an octopus is physiologically capable of walking backwards doesn't make it the best form of escape. Or does it?
When octopuses jet to escape a predator, there's so much internal pressure that's built up inside of their mantle cavity or inside of their body sac that it actually stops their hearts briefly.
Going into cardiac arrest while swimming away in a panic probably isn't ideal.
Walking backwards allows them to use 2 of their arms for locomotion and 6 of their arms for camouflage or to otherwise make their shape seem unrecognizable.
And while only a few species thus far have been documented fleeing on foot, or rather arms, Dr. Hufford believes that this escape plan isn't a difficult trick to pull off.
Just the way we don't have to stop and think, move left leg, move right leg. It's a type of motion called feed-forward movement where it's almost automatic once it gets going. And I think it was part of their normal locomotion repertoire of how they can move around.
Yet another method for these skittish invertebrates to show off having no backbone. For Science Friday, I'm Luke Groskin.